Hey everybody, lesson 2-1. Pretty straightforward, solving some simple equations by combining like terms. So if you turn in your book to whatever page lesson 2-1 is on, which is the page after the beginning.
86 and 87.
It's 86 and 87, I believe, if I am correct. We're going to watch this video, again, combining like terms, solving equations, stuff you guys have somewhat done before, but 8th grade we make it a little bit tougher. So here we go.
You were right on those pages, Mr. Earl.
How do you solve the equation?
Pause for a second. We may want to turn the volume up a little bit.
Let's go now.
Now,
That
let's go.
contain like terms. Think about this question during the lesson.
Now you may be wondering, what are like terms? Like terms are terms that have the same variable raised to the same power.
Ooh.
Gianna has 36 yards of fabric to make sets of matching placemats and napkins. It takes 1 1/3 yards of fabric to make a placemat, and 1/6 yard to make a napkin. How many matching sets can she make? You can draw a bar diagram to show how the quantities are related. The entire bar represents the total amount of fabric Gianna has to work with. This part of the bar represents the yards of fabric needed to make X number of placemats, while this part of the bar represents the yards of fabric needed to make X number of napkins.
Now remember, placemats are 1 1/3 yards each. Napkins were 1/6 of a yard each. That's why we're multiplying it by the number of sets we're making.
Why can you use the same variable to represent the number of placemats and to represent the number of napkins? Gianna needs to make sets of matching placemats and napkins. That means she will make an equal number of each. How would a diagram help you write an equation?
I don't know.
A diagram would help you visualize the relationship between quantities. Now use the diagram to write and solve an equation. The diagram shows that 1 1/3 x plus 1/6 x is equal to 36, the total number of yards of cloth.
Now remember, you 8th graders, they're going to go through some stuff here and talk about finding common denominators. The beautiful thing, we have calculators, okay? So this process that they're going to go through with changing them to common denominators, we don't really have to
We don't
do
have
because
to do?
we don't have to.
Mr. Noel, can you make sense of this? I don't understand the bar diagram and then how they got this equation over here. Can you make sense of that for me?
Yeah, okay? So when we look at this bar and this bar together, so this term here represents this bar and this bar together. That word together must mean to add. So if I take this term plus this term, those have the same length as this lovely green line up here, which represents 36 yards.
Ah.
So these two added together are equal to the 36 total yards of fabric that we have.
I got it.
Does that help, Mr. Fricke?
That helps. Thank you very much.
You bet.
Convert to like fractions. 8/6 x plus 1/6 x is equal to 36. Because the two terms are like terms, we can combine them. What is the sum of the two terms on the left side of the equation?
Select your answer.
Ooh. This is a doozy here. What is 8/6 plus 1/6?
Well, since they have common denominators, we simply just need to add the numerators and keep the denominator. So I'm going with this one
9/6.
over here.
Okay.
Nine 6 x is equal to 36. Use multiplicative inverse to solve. 6/9 times 9/6 x is equal to 6/9 times 36. So x is equal to 24.
Can't we just divide that?
Now, folks, let's go back here to this multiplicative inverse.
Make that bigger for you.
Yeah, okay. Now, if we, here it is. I were to just write this equation, 9 over 6x equal to 36, okay, they use what's called the multiplicative inverse because ultimately when you divide by a fraction, and this is something Mr. Boldazar would love you guys for if you were to say this, because you learn it in 5th grade, because sweet little Jilly right now learning about dividing fractions. No, she's not. Okay, either way, you multiply by what's called a reciprocal. Well, again, you guys have these little calculating devices. You don't need to multiply by the multiplicative inverse. All you need to do is basically take each side of the equation and divide by the coefficient. Now, some of you may be saying, Mr. Noel, what's the coefficient? You guys know the coefficient as the number beside the variable. So all we got to do is divide by the coefficient. If you do it to one side, you got to do it to the other. So multiplying by this thing they call the multiplicative inverse is the same thing as dividing by that fraction.
I think they're good now.
Oh, clear as mud, everybody. All right, let's continue on.
Gianna has enough fabric to make 24 matching sets of placemats and napkins.
Awesome.
So if X is equal to 24, 32 yards of the fabric will be used to make placemats, and 4 yards to make napkins.
Sweet.
Now you can solve more complicated equations by combining like terms.
Bring on the complicated equations.
That's right. Let's do some more. You want to?
Yeah, let's go to the triad.
Let's go to the triad section. Come on, go! There it is. All right, so it says, or we'll have somebody read it instead of me.
Selena spends $53.94 to buy a necklace and bracelet set for each of her friends. Each necklace costs $9.99, and each bracelet costs $7.99. How many necklace and bracelet sets, S, did Selena buy?
Well, she spent a total of $53.94. So if we analyze this equation over here, the total is set up to be the total amount that she spent. Now, what did she buy? She bought some number of necklaces and some number of bracelets. Okay, now those come in a set. So how many sets? How much did it cost per set for each necklace? I think the coefficient of this should be $9.99.
Yes.
Okay? Now, this second part, because the sets are necklaces and bracelets, this is going to talk about the cost per bracelet, which is $7.99 per set. Okay, well now let's think. How much do these cost together? That's why they're like terms. They have the same variable, and we can combine those to figure out what is the total cost per set. Well, I think this comes out to be $16.98.
17.
Oh, wait a second.
We got all them 99s in there.
Whoa, my bad.
Whoa.
$17.99.
98.
Oh my goodness, I am.
It's late in the day, guys. Mr. Knoll, he's used up all of his math brain power. It's okay. It's all good.
$17.98. Here we go. So $17.98 times the number of sets equals to $53.94. We're going to use inverse operations. Instead of multiplying times the number of sets, we're going to divide both sides by that $17.98. Now, I believe I can do this one in my head.
Not one, not two,
3.
but
She
3.
can buy 3 sets
Yes.
of bracelets for her friends. What a nice young lady.
Good work, Selena.
Seriously. How many of you guys would spend that amount of money on me?
Just me, I think.
Yeah.
Yeah.
Okay, well, let's go to example 2. Oh, I can't wait to see what this one
This is a good one here. Percents, baby, coming back.
Yes! Man, we had Selena, and now we have Celine.
Yeah.
Celine bought a computer screen on sale for 35% off the original price. What was the price of the computer screen before the sale?
She didn't buy the rest of the computer, just the screen.
I guess. Just the screen.
Huh?
So, once again, we could draw a bar diagram for this. Okay, now this one a little bit different because we do not know the total cost for this computer screen. All we know is, hey, they took off 35% of the price, and she still had to pay $130. So together, okay, together these two would equal the total price. But if we don't know the total price, I can't add these two together to be equal to this. Maybe we should do the opposite of that.
The opposite of adding?
Don't you think we could subtract?
Yes. I think that's what they're doing, folks.
So folks, we're going to set this up. Hey, to find what this original price was, we are going to take the price that it cost. Now remember, we got 35% off. Mr. Stair, Mr. Treen taught you guys about percents last year.
That's right.
So a discount is a decrease in price, so we're going to subtract the 35% of the price, and it's going to equal the $130 that we actually spent.
Mm-hmm.
Now, these are what we call like terms, same variable raised to the same power. But the problem here is there's no number beside that letter.
Yes, there is.
Where is it?
It's right there.
It's a 1.
Ah.
If there is no coefficient, the coefficient is always 1, my friends. So, when we take and combine like terms, we just simply either add or subtract them together. Well, in this case, we are subtracting. Well, if we take 1 minus the 0.35, that comes out to be 0.65, or 65 hundredths times P.
Ooh.
So, last step. We're taking a coefficient, multiplying it by a variable. Inverse operation says do the opposite. Folks, we're going to divide both sides by
0.65.
65 hundredths, or 0.65. And folks, if you do that correctly, that would come out to be $200.
Oh, bam.
A computer screen, $200. Oh, I bet you there's a try it.
I hope so.
And there is.
Yes.
Nat's grocery bill was $150, which included a 5% discount. What was Nat's bill before the discount? Right? Solve an equation. Well, if I were to draw a bar diagram, we know it's going to be two different pieces. And they always have this line that represents the total. Do we know what?
I think we do. What do you think, folks? What's the total?
What was it before the discount, though? We don't know this.
Oh.
Sorry, don't know it. But we do know she paid $150, and we also know that she got a 5% discount. Now, folks, 5%, we got to change, 5% to a decimal. Percent means of 100. So ultimately, if you take 5 divided by 100, you will get the decimal value, or your teachers have probably taught you move the decimal spot 2 places to the left. So 5% is equivalent to 0.05. So she got 5% off of the bill, or of the total. You with me there? Thought so.
They're with you.
Okay, so looks like these two things added together equal this. Or, since we don't really know the total, maybe we should subtract again. This minus this is equal to this. That sounds like a good idea. 0.05 equal to 150. This is where I got to have Mr. Fricky. He's back there calculating right now. That's what he does.
That's what I do best, folks.
Step 1, hey, if there's multiple terms with the same variable, we combine those like terms. Well, once again, no coefficient. Yeah, there is. It's 1. Combine them together. We got 0.95 times x equal to 150. Last step to solve this. Here's your coefficient, multiplying the variable, inverse operations. Divide by the 0.95. Mr. Fricky's calculating this bill.
$157.89.
Holy smokes. That bill before the discount was $157.89.
Yeah.
Awesome. Okay, example 3.
Fun's not over.
No, we got more. We have got more. I wonder what we're going to do now. Oh my goodness.
Woo.
Now we have what are called negative coefficients. Now you got to go back and think about what you do and how you combine terms that have negatives. So,
That brings back happy memories with Mr. Strayer and Mr. Treen, I believe.
absolutely. So, talks about here, get off of there. Says to combine like terms with negative coefficient, use the rules that you learned for adding and subtracting numbers. So, ultimately, again, this is what's nice about 8th grade. Do you really have to remember all those rules? Well, hopefully you do, but ultimately, all you have to do is type it in the calculator correct. The calculating devices. If you were to take negative 3.5 minus 6.2, those would combine to be this negative 9.7. There's really nothing new. It's just combined negative numbers. Okay, let's move on. Oh. Too many buttons there. Try
A lot of
it.
buttons.
Try it. If you want to pause it, solve these on your own. Come back, check it out here in a second. Step 1, hey, these two things have the same variable. They're called like terms. Combine them together. Negative 1/4 minus 2/5. Well, these would both have denominators of 20. This would be 5. That would be 8. This seems like it'd be a negative 13 over 20.
Ding, 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 ding.
Okay? So there's our fraction times our variable equal to our value. Folks, I draw this line to separate our equations into 2 halves, okay, so that I remember whatever I do to one side of the equation, I must do to the other. But ultimately, it's showing multiplication, so I need to divide by that coefficient. Be careful here, because this coefficient is negative, so you're dividing by a negative coefficient. Value there, wait, 60, negative 60.
Negative 60. Nice job.
Boom!
I didn't use my calculating device either. I used brain power on that one.
That's right. Okay.
Okay.
Letter B. Once again, these have the same variables, so we can combine them together as we solve. If you remember back in the good old days, subtracting a negative number is the same thing as adding a positive value. So when you type this in, don't be surprised by what you get. Don't be surprised. But I think if you were to combine these, we've got a 3.05, Mr. Freeman.
Yeah, that's right.
Okay? So those terms combined equal to 8.54. Once again, solve using inverse operations. Boy, it seems like we're dividing a whole lot.
We always divide by that coefficient.
Divide by the coefficient. Boom.
2.
The value of D equals
2.8.
2 and 8/10. There you go. Folks, there's examples on page 86, 87. Combining like terms, just be careful as you combine them. Keep the signs that you need, and other than that,